So here we're going to look at another type of complex rational expression. One that actually at first glance doesn't seem to be a complex rational expression because it doesn't have fractions currently in it. However, it does have some negative exponents. You'll see x to the negative 1 minus y to the negative 1 all over the quantity x minus y to the negative 1. Remember, negative exponents can change to positive exponents when moved to a denominator. And so we could rewrite this in the form of a fraction, a complex fraction, where x to the minus 1 is really 1 over x. And y to the minus 1 is really 1 over y. And x minus y to the negative 1 is 1 over the quantity x minus y. Okay, so now we've created a complex fraction based upon the negative exponents. Now it's a matter of trying to get these fractions together. Now the bottom is already a single fraction. The top has 2 that I want to combine into 1, and so then I can do my copy dot flip step. So on top, I know that my LCD is the product of the two denominators because there's no common factors. So xy is my LCD. Maybe I'll take this off to the side here for a moment and work on that numerator. So just to keep from having to write down excessive things multiple times. So I have my numerator here, 1 over x minus 1 over y. The LCD is xy, so I'm going to multiply the first fraction by y on top and bottom, the second fraction by the x on top and bottom. And so I'm going to be left with y over xy minus x over xy, right? And so when I combine those, I'm really just looking at y minus x over the product of x and y. This is my new numerator. I'm going to put that in place of the two terms on top. So that's going to be y minus x over xy all over 1 over x minus y. All right, so it is a complex fraction, right? I've got a single fraction on top. I've got a single fraction on the bottom. Remember, this big division, this big fraction is a division. So we're going to copy dot flip to finish this off. So I'll take this over here to the side. We're going to start by copying the numerator, then doing a dot, and then flipping the denominator, okay? At this point, we don't really get anything to cancel nicely. And so, right, as long as I did that right, copy, dot, and flip, yep. And so now I just need to multiply across to get everything in one fraction. So I'm going to have my product of y minus x on top with x minus y. And then on the bottom, I have just xy. Okay, and there we have it. Now we could do some simplifying at that point. What I'm noticing is that I have a y minus x and an x minus y. I could get the signs to be the same by factoring out a negative 1 from this first factor. And then I might just be able to clean this up a little bit. It's not a big deal to do this. I just kind of like to see if I can get it to look even simpler. So if I pull out a negative 1, the y minus x becomes x minus y, right? Because the signs would both change. So then I also have another x minus y over here. And then an xy on the bottom. And because now I have two copies of the x minus y, I could write that as x minus y squared. So you might have a negative quantity of x minus y squared all over xy. That might be the simplest way to write it. I'm sure there are other ways to write it. I would really accept any of these, sort of from that point down, but I kind of like this this bottom one. It's the most succinct one that I can come up with. So kind of an interesting problem. Again, it doesn't initially start out looking like a complex rational expression, but we can turn it that way by utilizing our negative exponent rule.